Okay, so we're going to look at an example that's to do with maxima and minima problems with variable acceleration. We've got a yo-yo leaves child hand and travels vertically before returning. The distance of the yo from the child's hand is s equals 0.6t plus 0.4t squared, subtract 0.2t cubed, I should say, for t's between 0 and 3 seconds. We're going to justify that restriction first of all, and then we're going to find the maximum distance of the yo-yo from the child's hand. Okay, so part A is justify that restriction. What we want to do is really we're going to find the time that it takes to return to the child's hand, which should be 3 seconds. So it returns to the child's hand when s is back to being 0. So it goes from 0, the yo-yo drops downwards, so it goes like a meter down or whatever, and then it goes back up, so back to where the displacement's 0. So we're saying s is 0. Therefore 0.6t add 0.4t squared, subtract 0.2t cubed must equal 0. We can factor out, well, we can actually multiply for 0 first perhaps. So if times everything by 5, I'd get 3t plus 2t squared, subtract t cubed equals 0. I can factor out minus t, and that would give me t squared, subtract 2t, subtract 3 equals 0. In fact, I can just ignore that now and make that to plus. I can factorise the quadratic part of that, which would be t plus 1, t take 3 as factors. So s is 0 when t equals 0, which is obviously a start, t equals minus 1, which is going to be irrelevant because you're not going to have negative time, and t equals 3. So let's just say yo-yo returns to hand when t equals 3, hence t must go from 0 to 3. Okay, part B, find the maximum distance of a yo-yo from the child's hand. So maximum, minimum, it's all to do differentiation. So we're going to want ds by dt to be 0. No, that's the same as the velocity in fact. So it makes sense actually, because that's the point you stop. The yo stopped at the bottom instantaneously, then comes back up. So the maximum distance is when v equals 0, i.e. ds by dt is equal to 0. So if we differentiate s, we get 0.6 plus 0.8t, subtract 0.6t squared, and we want that to be equal to 0. And like before, we can multiply it all up to make it into a neater looking quadratic, which would be this, or possibly change it all to plus 3t squared there. And then maybe we can factorise it, maybe not, I'm not actually sure, but we'll solve it one way or another, so maybe using a quadratic function on your calculator. Okay, so it wouldn't factorise in fact, and the two solutions I get are t equals 1.8685, or the other one I get is negative, so t is greater than 0, so t must be 1.8685. We want to substitute that in to find what that distance is. So for that value of t, we're going to substitute into the equation for s, which is what we started with in the question way up there now. So for that I get s to be 1.21 meters. We just need to check that's the maximum or the minimum. It feels kind of obvious that it should be the maximum, but just to prove that, we want to get the second derivative. So d squared s by dt squared. So we're differentiating this thing here. So that would become 0.8 take 1.2 times by t. And if I substitute the value of t that we just worked out into that, we get minus 1.4422, which is obviously less than 0. Therefore, s equals 1.21 is the maximum distance. And that's that question done.